Hi everyone. In this video, we are going to see a presentation about the implementation of filters by using a Python code, which includes an identity kernel of a 3 into 3 NumPy matrix. Okay, first let us see what is filtering. In digital image processing, a filter is a mathematical operation which is applied to an image to enhance certain features like remove noise or perform other modifications. Filters are typically represented as matrices, which is also called as kernels or masks, that are applied to each pixel in the image. Filters have various types. Let us see what are there. The first thing is linear filters. Linear filters are filters that satisfies the properties of additivity and scaling. Convolution is a common operation used to apply linear filters to the images. The second thing is nonlinear filters. What are they? Unlike linear filters, nonlinear filters do not satisfy the properties of additivity and scaling. Example, median filters and max filters, which are often used for the noise reduction. The third one is spatial domain filters. These filters operate directly on the spatial coordinates. For example, smoothing filters like the Gaussian filter and the sharpening filters like the Laplacian filter. The fourth one is frequency domain filters. These filters operate on the frequency components of the image, typically after a Fourier transform. They are used for tasks like removing periodic noise or enhancing specific frequency bands. Here is the representation. So, the image filtering techniques can be classified as follows, like spatial domain and the frequency domain. Spatial domain can be classified into linear filter and nonlinear filter. The nonlinear filter can be classified into SMF, AMF, DBMF, DBUTM, edge preserving filter. Okay, the next thing is kernel. What is a kernel actually? Let me tell you. In the context of digital image processing, kernel is a small matrix used for various operations like filtering, convolution, and image transformation. The kernels are typically a square matrices with odd dimensions, like it may be 3 into 3 or 5 into 5 matrices, and are applied to each pixel in an image to produce a new pixel value. The kernel has various operations. Let us see what are there. The first thing is convolution. So the convolution slides a small matrix over an image, multiplying and summing its value with the image pixels. The second thing is cross-correct correlation. It's like a convolution, but without flipping the kernel, it measures similarity between two signals or images. The third one is median filtering, which replaces each pixel with a median value of its neighborhood. The fourth one is max pooling. Max pooling downsamples an image by taking the maximum value in each region. It is often used in neural networks also. The fifth one is Gaussian smoothing, which blurs an image by convoluting it with a Gaussian kernel, which is also used in reducing the noise. The sixth one is Sobel operator, which computes the gradient in x and y directions to highlight the edges. Okay, let us see the Python code implementation. It has 5 steps. The first one, we need to read the test image. Next, we need to define the identity kernel as mentioned at the starting of the video using a 3 into 3 numpy array. Okay. Use the filter 2D function in OpenCV to perform the linear filtering operation. Then we need to display the original and the filtered images using the IMShow function. Save the filtered image to the disk using IMWrite function. Okay, now let us see the execution of the code. First of all, we need to import the necessary libraries like CV2 and the NumPy. Here, the CV2 is used for image processing and the NumPy is used to read the arrays. Now we need to read the test image. So give the path of your input image over here and read the test image by using imread. The third thing, we need to identity a kernel. And as mentioned earlier, we are using here as a 3 into 3 numpy array. Then we need to filter an image by using filter 2D. The next, we need to display the original and the filtered image using imshow. So cv2.imshow original image and cv2 imshow of filtered image. The next, we are using here wait key. The wait key is used to wait indefinitely for a key event. At last, we need to save the filtered image to the disk using imwrite. And I have used the image of a fox over here. The result I'm getting after the execution of the code is displayed here. And that's it for today. Thank you.